All right, well, I guess we can go ahead and get started. Welcome, everyone. So this special seminar series is on ForecastR and program updates and capabilities. Just to kind of introduce us here, so this is a webinar format, so every attendee is muted, and you can type your questions in the chat, in the Q&A, and then they'll be answered throughout the talk. There's kind of two good spots to ask and answer some questions, and we'll kind of open that up as we move through the talk. So if you do raise your hand, we can unmute you here. So if you would prefer to ask your question live instead of typing in the question and answer Q&A, you're welcome to do that, and we can just unmute you. All right. If you type a question in the question and answer, you have the option to upvote your answer just with the little thumbs up, and it kind of moves it up in the queue. All right. So I've got Dr. Antonio Velez-Espino. He will provide an update on current capabilities on the Salmon forecasting tool, ForecastR. So ForecastR relies on the open source statistical software program R to generate age-specific or total abundance forecasts of salmon escapement or terminal run using a variety of generic models and enabling users to perform interactive tasks, which help with the help of a graphical user interface developed as a Shinyapps. These tasks include the selection of forecasting approaches from a wide set of statistical and/or mechanistic models for forecasting terminal run and escapement, the selection of several measures of retrospective forecast performance, the comparison of forecasting models and model selection and ranking, and the reporting of forecasting results and diagnostics by producing detailed or summary reports. So after 5 developmental phases, the latest release has successfully implemented all of the original envisioned capabilities for this tool. Woohoo! And additional information on the project can be found on the GitHub site, which is in the original announcement for this talk. The Shinyapps allows online forecasting exercises without users having ForecastR or R installed on their computers, which is quite helpful. ForecastR has been used to produce Chinook agency forecasts for Canada and Oregon for the Chinook, the PSC Chinook model since 2016. And with that, I will send it over to Antonio.
Awesome. Thank you very much, Jess. I appreciate the introduction. And I also would like to thank Kim Bartlett and John Son for helping me setting up and getting comfortable with Zoom. So this is great. Thank you very much, everybody, for joining today. My name is Antonio Velez-Espino. I've been with Fisheries and Oceans for 15 years now, which is pretty incredible. And I've been a member of the Chinook Technical Committee of the Pacific Salmon Commission for almost 13 years now. And currently I'm the Canadian co-chair for that committee. So this first slide, I decided to use in this presentation a mix of slides from different presentations. This is from one that I gave a 5-minute presentation a few years ago at the commission in Portland, I remember, for this kind of contest that it was called, I think it was called the Data Dragon's Den. And so everybody had 5 minutes just to present, and the presentation supposed to be funny. So that's why you see all those elements there already. Yeah, and I have the feeling that I'm forgetting to thank somebody at this point. Oh yeah, I also would like to thank the PSC Secretariat and John Field for the opportunity to present this and let folks know what is the state of the art of this forecasting tool. So, I mean, as a member of the Chinook Technical Committee, you can imagine, I mean, forecasting of terminal run and escapements is very important in our process, right? At some point, we realized that, we didn't have much information about what different agencies were doing or about the accuracy of the forecast. So it was kind of a initiative of the Chinook Technical Committee to start a project allowing us to quickly undertake exploration of forecasts and evaluate the performance of different forecasts. And that's how the ForecastR project started. Some people call it ForecastR, other people call it ForecastR. It doesn't matter, and I prefer to use ForecastR. It sounds better, according to me. So yeah, so in 2013, we benefit from some PSC funds to the Chinook Technical Committee, or CTC, for what was called the Model Improvements Funds. So we were able to get the project going, and by 2016, we had a very good progress on the original vision for this particular tool. At that point, there was the commission contracted a forecasting review expert panel just to evaluate the forecasting performance within the Chinook technical work, and particularly the Chinook model and the agency forecast provided to it. After that review, the panel got an understanding of ForecastR, and they provided a recommendation to use ForecastR, but also recommended adding additional forecasting modules, like, for example, the Kalman filter sibling regressions, right? For those that are familiar with salmonid forecasting, sibling regressions have been and are going to continue being important forecasting models for salmonids. So thanks to those recommendations, we were able to submit proposals to the endowment funds and get additional funding for the development of additional tools and capabilities during 2016, 2018. And after that, there was still work to be done, and we were able to continue working on this project during 2019 to 2021, thanks to TFO funding. So what was the vision of ForecastR? The idea was to incorporate a variety of statistical modeling and forecasting tools that can improve the quality, but also that can expedite the process. And originally was designed as a Chinook only forecasting, but at some point we realized that, what we are doing is actually important, and is going to be useful for any other salmonid species, right? The idea of using a tool like ForecastR is not to actually to replace some of those tailor specific forecasting models that some people use for individual stocks, but rather just to see how their perhaps more complicated modeling approaches perform relative to some of the generic models that we have in ForecastR, right? An important part of the philosophy of developing this tool is was to facilitate communication and the ability to share forecasting results, right? So transparency was very important as part of the original vision. The main features, like Jess mentioned in the introduction, is that, we allow, ForecastR enables users to forecast escapement, terminal run production. It can be of individual stocks or aggregate stocks. And now in the latest and greatest version, and that's what I decided just to provide an update, because now that we are observing lots of environmental change and kind of trends in environmental variables, it was really important to incorporate the ability to read some of those time series of environmental covariates and see how they influence forecasting. ForecastR, there are two main types of data that can be read. One is going to be age-specific data, right? If users have that information, is going to guarantee better quality forecast, but also in some cases, users only have total abundance, a time series of total abundance for a number of years. And ForecastR has a series of time series models and naive models that are also, that can be useful for those kinds of data, right? So those are the main two types, age-specific or total abundance. And the suite of generic models is what has been growing over the years, usually as a result of recommendations from the CTC or from users. So, I mean, these are kind of some of the main attributes that we of a good forecast and the forecasting process, right? That it has to be defensible, useful, robust, right? In order to be defensible, it has to be plausible, it has to be meaningful, it has to be reliable. To be useful, it has to be easy to use and transparent, properly documented, it has to be timely, right? So in that way, a tool like ForecastR has enabled us to expedite the forecasting exercises and provide recommendations at the right time. It has to be robust, meaning that it recognizes uncertainty, accurate, I mean, that there is good retrospective evaluations. And an important feature is that it has to be flexible, meaning that we are working within a model selection process. And I'm highlighting this one here, this particular attribute, which is one of the good forecasting practices, is flexibility. That means that it's important to accept that no single model is going to be the best at all time. I know that as we start doing this kind of work in our agencies or wherever we work, we kind of develop particular attachments with the forecasting approaches that we are using, right? But it's important to recognize this kind of flexibility attribute, that there is no single model that is going to be the best all the time. So based on that, model selection should be at the very heart of forecasting exercises. And that's one of the aspects of ForecastR that we have developed to a very good level now. So all of that grand vision was kind of conveyed into a 2019 report that that we submitted to the Pacific Salmon Commission, right? So this is going to be one of the sources of information and details where users can go and actually review what is there in more detail, right? So Jess also mentioned about that ForecastR is relies on R, right, which is open source software. And it consists of two main products, right? It has an R package and it has a Shinyapps. The Shinyapps relies on the R package, but the Shinyapps has several additional functions and attributes that are not in the R package, right? So in the rest of the presentation, I'm going to focus exclusively in the attributes and capabilities of the Shinyapps. So this Shinyapps is, if some of you have experience with some of these Shinyapps, I mean, it's a great resource because it's going to provide a graphical user interface that facilitates interactions, right? And importantly, I mean, any user of the Shinyapps doesn't need to use R or to have ForecastR installed in their computers, right? That's what that baby face says. Say what? Yeah, I mean, you can even run it in your phone or in your tablet, right? As long as you have access to your input files, right? In a Dropbox or wherever you can have it, you can run it in your phone or your tablet as well. What you need is a good connection, internet connection, and that's what I'm hoping for today, that my internet connection works well so that we can have a live demonstration here. So, I mean, this is kind of an schematic of what is happening in the app, right? You can see at the bottom, at the top, kind of different families of models, right? Where users can select, they can within the app, they can not only select the models, but they can select the performance measures that they want to incorporate in their analysis, the bootstrapping methodologies, the different ways of model ranking, the years. I mean, you can have an input file with 200 years, but you only want to use the last 50 years for your forecasting exercise. So you can do that within the app. And then you can select what kind of report you want to generate, right? So at the end, the app is going to allow users to explore their models very, very quickly, as we will see, to undertake this model selection very quickly as well, and also to acquire reports of and document all the decisions that users took along the way. So to run the Shiny app, we have currently two Shiny servers. One is the Pacific Salmon Commission server, and the other one is the Solve Code link. Those are the two links, right? And as I mentioned before, you don't need to have R installed in your computer or ForecastR, right? So now I'm going to stop there before we give it a try to a live demonstration to see if there are any questions that I can address.
Thanks, Antonio. I'm not seeing any right at this moment on the question and answer tab, but maybe wait a minute here in case people are typing.
Let's give it 10 more seconds just to see.
Sure. Oh, so one question.
I see something in the chat there. I see 6 in the chat, 7, and a Q&C too. But I don't know if I can access that.
Sure. Yeah, I do see a couple of questions here in the chat.
Okay.
So I have one question. Does it run on any platform?
I think more specific.
I think maybe does it run on like any Internet Explorer platform, or like Apple versus Microsoft?
That's actually a very yeah. It should work in any platform. Yes, and in any browser as well. Yeah.
Great. Another question here. Is there a user manual about ForecastR?
Yeah, so there are 2 main sources, and once we go to the live demonstration, I will show you how to access that. So there is the report that I showed the cover page in one of the previous slides, but there is also the wiki page on our GitHub site that is available to everybody. So people can go to the wiki and basically start looking in more detail at the different components of ForecastR. Yeah.
Great. Yeah. Thanks, Antonio. And the link to the GitHub page is in the chat there too, so you can take a look. There's also some questions in the Q&A if you want to address those too.
Sure. Yes.
Okay. So I have a question from Tommy Garrison that says, can you model average forecasts based on retrospective performance?
I think that the question is referring average from the output from different models, and not yet, but that's something that is in the list of items to add to the next phase of development. There has been interest in model averaging, yes.
Great. And then I have another question from Maren Haig. For environmental covariates, are there ones already included in the ForecastR package, or do users provide their own?
Yeah, users will provide their own. Yeah, and I mean, with environmental covariates, I mean, it's going to be up to the users to decide whether that particular environmental covariate is going to be lined up to calendar year or brood year, right? It depends on the kind of ecological, biological interactions, right? With the survival of salmonids, for example, right? And also it's up to the users to decide whether there is a time lag, because sometimes the effects of environmental factors don't occur instantaneously, so we're going to observe them in subsequent years. So it's very normal to see time lags of 1 year or 2 years, right? Yeah, and a forecaster doesn't do that, and it's up to the users to kind of get together their environmental covariates and just incorporate it into the input file. So when we get to the complex sibling regression, we can I will provide more information about environmental covariates.
Great, thanks. I have another question from Catherine McKelson. Excellent presentation. ForecastR is a great tool to make advanced forecast methods available to others. Even for technical committees that are already relying on their own methods, this tool allows them to quickly explore some additional methods to figure out if they would be useful to adopt/adapt for their purposes. Also, the incorporation of environmental data is great to see. My question: are there any plans to have users contribute environmental time series that could be used by others?
I think that's a great suggestion. I'm going to write it down. If we can create in ForecastR the space for users to provide time series of environmental covariates, that's a very clever idea. We haven't thought about that, but I think that is great. Yeah.
Fantastic. And then I have one more comment here that from Roger Dunlap that says, Brian Rush put our short Berman River data with only 10 years of age and mark recap data in, and it worked. So.
Oh, really? Oh, that's great. Okay. Thank you, Roger. Appreciate it.
Great. And I have one more question here. Maybe we'll hold off after this one and move on to the demonstration. But from Eric Taylor here, do users show any preference for using the application deployed on shinyapps.io or on their own machine by downloading the repository?
Well, it depends. I guess that our power users, they will prefer to choose the package, I think, and for that, yes, they will go to the repository and create their local repository, and yeah. So we have also instructions in the wiki about some the most relevant command lines and examples of scripts that will get our users started, right? Yeah.
All right, fantastic. All right, so I guess maybe we can move on to the live demonstration and hopefully everything works.
Cross my fingers. Okay. So as you can see, I put here a plan B. So I have a bunch of slides, and in case my internet crashes. Well, I guess if my internet crashes, and I cannot even talk to you anymore. Well, let's see. Here we go. So, so I'm going to a browser, and as you can see, I already have here kind of some bookmarks for the two possible access to ForecastR. So it should be coming anytime. Can people see it?
Yep, we can see your ForecastR.
Okay. Well, hopefully the print is not too small for folks, but this is kind of I mean, when you open ForecastR, this is what you see, right? There is important that is a disclaimer here that obviously, I mean, like many of these open source projects, they come without warranties or liabilities. So don't blame us if something goes wrong. But also, I mean, there is no quality control, right? ForecastR doesn't do any quality control. So that is up to the users always just to take care of that. And also, there is lots of opportunities to make decisions during when you run the app. So obviously, I mean, it's responsibility of the user just to make decisions and explore things thoroughly, and as part of their forecasting exercise. So there are links here. There is a link if you start working and playing with the tool and find issues, right? You can report those issues here. And so we check these oftenly, and we try to take care of things. And what as you can see here, there is also access to the wiki that I mentioned. Can people see my mouse when I move like that?
Yes, we can.
Oh, that's awesome. Okay. And also, this is access to the actual report that I showed before, right? So as you can see, ForecastR has, in addition to the disclaimer, a number of tabs here, right? My recommendation is always to start with the about, right? At least for first-time users, right, where you can get additional information. You also have access to the report here, right? There is some overview of the project. And in the help tab, you have access to the main repository. Here you will find everything that you need to know, including the R package if you are interested in that. There are some samples of input files. The input files are very simple. As I mentioned before, there is one for age-specific data, and there is one for total abundance in the case where users don't have age-specific data. For R users, there is also access to a demo script just to get you going. And again, another link here to report issues. And then we have some kind of statistical the identification of some problems with your time series. So the first step, once you are ready to start forecasting, is to load your data. So you click your data loading, right? And here you have another opportunity to see an example of a sample data, right? So I have the input file in my computer already. So I'm going to browse it. And I'm going to load it. And here you can see that, I mean, this is the input files are CSV files, right? This information here is important because it's going to appear in your figures, tables, and reports as well, right? So we're dealing with at Narco Chinook. I'm trying to forecast escapement, and the forecasting year is 2021. I have my run year data, brood year, the age classes, the escapement values observed, and then I have also 3 covariates, right, here. And I have a predictor too that is going to be used for the return rate model, right? Yeah. So this is the input file. And if you don't have age-specific data, you can imagine how simplified this file is going to look with only a column for run year and a column for escapement or terminal run or production, whatever you are doing, right? And as I mentioned, some people have been using the total abundance forecasting capabilities to forecast other things, right? We have used it to forecast maturation rates, for example, right? You only have to trick certain aspects of your input file to make it work. And yeah, I mean, if people are interested in forecasting other things or other species, I know that people have used it to forecast lamprey, for example, right? And so if the life cycle biology of the species you're trying to forecast can be adapted to any of the available models, why not, right? And so once you have your input file, there is another tab here that we are still working on it. This one is that when you include in ForecastR, covariates are part of the sibling regressions. So it's still a sibling regression where the abundance of previous ages is an important predictor, but also you can add up to 3 environmental or biological covariates, right? So there is going to be model selection within to see which one of those potential models, depending how many covariates you provide, is the best. So, but we noticed that these covariates can be of very different scales, and sometimes they kind of produce forecasts of really poor performance. It really helps if you scale them, trying to bring all the covariates relative to the maximum value in your time series, right? And then there is a couple of settings here that are not linked yet. One is if you are working with fractions, right? I mean, how many decimals you want to show in your tables. If you want to forecast something that is not escapement or terminal run, here you can enter it, so it will show in your figures, and you can show it will show in your reports as well. But as I say, this is still work in progress. So now we're going to jump into the into one of the main features, which is the Explore tab, right? In the Explore tab, here in the left panel, well, you have all the available models, and this is smart, right? If your time series is it doesn't have age-specific data, it's not going to show you all the sibling regression models or all the return rate, for example, right? If you don't have environmental covariates, it's not going to show you the complex sibling. If you don't have predictors for the return rate model, it's not going to show you the return rate. So we're trying to make all the menus smart that way. We are making progress, getting there. And here you can see, I mean, you already have, I mean, the blue line is your observed time series, right? In this case of escapement, the red line is your forecasting, right? And then you have the forecast for the year for which you are interested, right? Which in this case was 2021 for all the ages, right? You change to, let's say, the return rate model, right? So you have the results readily available there, right? At the same way, you can see other tabs. So this is the kind of the prediction intervals. And I'm going to skip here to the prediction interval here. There are three types, a retrospective, right? The prediction and the bootstrap. Obviously, the bootstrap is the best one, right? Because it's more robust. It takes a little bit of time, right? Because there is more computations, but as you can see, it's still pretty good. And I'm only running it with 100 samples. A recommendation when you are, after you explore and you are ready to do your forecasting, to increment the number of samples, right? There are different types of bootstrapping, and but this is something that I know that the participants of this webinar maybe interested in some statistical details, others not that much, more about the functionality of the app. But I'll be able to address some of the technical questions maybe today or offline. Right? So then you have a forecast table that, I mean, all the calculations have already been made behind the curtains, right? So you have your point forecast, you have your percentage, your median. You can compare how the point forecast compares to the medians, for example, for the different ages, right? And you move to a different model, right? Like in this case, is the time series exponential smoothing. So it will, yeah, this error message is going to show during the computations. If the error shows and you don't have the wheel spinning here on your top right, that means that, I mean, there is something wrong with your input file, or we are really pushing Forecaster with I mean, reading or doing the forecasting for a particular module is challenging for a reason. There is always a reason, right? Sometimes you can find it that quickly, sometimes it takes time. So yes, and then we have a time series, the box cost transformation here for time series, which smooths the time series prior to forecasting, and then there is a back transformation, right? So you can select that one too and see how that changes your forecasting. Right? So it's taking a while. Oh, there it is. So these two bars here, sliding bars, right? They are very important. Let's say that your time series, as I mentioned before, it goes all the way to 1950. But you just want to start your forecasting. You are not interested in the first 25 years of data. So you can select when to start, right? I assume that for some models, it depends on the model, right? Let's see what happens if I bring it here. Yeah. If you have a naive model, nothing, what you have in this table is not going to be affected by moving the bar here, because it's based, naive models are based on averages of previous years, right? And this is based on and this is another very important sliding bar, which is to decide how you want to seed your first retrospective application. So retrospective evaluation, I mean, in case there is any doubts, is asking, it answers to the question of what would have been the performance of a particular model if I would have applied it in this particular year 20 years in the past, for example. So in this case, if the time series starts in, let's say in 1980, right? We saying that we want to start the retrospective after 15 years. So the first model is going to take the years 1980 to 1995, and it's going to produce the first forecast. It's going to compare it with the observed, and it's going to produce, and there is going to be an error, right? And that error is going to be quantified in some of the metrics that we will see in the next tab when we go to the compare tab, right? So it's really cool because there is a bunch of diagnostics here, very difficult to go to all of them in detail. But you can see you have the observed versus fit, the residual versus fit, the residual pattern, histograms, and there is some model specific stuff, like here says, I mean, this only works for the sibling regression Kalman, the Kalman sibling regression. So if we go there and we select the Kalman regression, then we are going to have the trajectory of the intercept, right? The Kalman sibling regression is basically letting loose the intercept, right? And you can see how the intercept is changing. So clearly, there are clear trends for H5s and 6, so that can help you in your forecasting exercise. How many years are you going to use as an average for your intercept in order to forecast the year of interest, right? So this is really cool. And then there is some model selection, right? So this one, as I said, for the sibling regression, because you may have a variety of models depending how many covariates you included in your input file, right? Here there is going to be a model selection based on the archaic information criteria, right? AIC, but also on your R squares from regression. So let's see. I want to select now the complex sibling regression, and now you see that there is a table here. You can see the different models. In this case, we are trying to forecast H4s, and it's saying here that the selected model by ForecastR is this one, which did pretty good. It was the best based on the AIC ranking. So the logic here is that you have a clear winner with the AIC. That one is going to be selected. If there is very close competition between 2 or more models, then it's going to go to the R square. Here are the kind of tolerance limits that you say. A difference of 0.75 is considered significant for the AIC values. A difference of 0.02, right? So you can play with this, and also to understand the support. What is the logic behind deciding what is a right tolerance level? But you can always rely on the defaults that we have there. So, and if you choose here, for example, H6, right? You can see that another model was used. Then in this case, it's being predicted with the H5s, but also the interaction between the 3. That's what it means, these brackets here. It means that it's based on the interaction between the 3 covariates. So what else to say from the Explore tab? Well, we also have the Bootstrap series here, right? And so I'm going to stop here. Perhaps I think that this is a good place to stop and see if there are any questions about the Explore. So I know that if we are idle in the app, if you leave the app idle, like, I don't know, I have never measured the time, but if you leave it idle for a few minutes, it's going to shut down, right? So how about if we take, like, I don't know, what's the time now? Like 4 minutes to take questions?
Sure. So you got just a couple questions here. So Andy Padilla says, is there a way to load sample data into the app that is not on Dropbox? Dropbox is blocked, is a blocked website for the state of Alaska.
Oh, well, you can have it in your computer, right? Like I do. I have it in a folder. I was mentioning Dropbox only when, in cases like you are working you're in an airport with your phone and you want to do some forecasting. So yes, you can have the file in your phone or on a Dropbox, right? So you can access your input file.
Great. All right. And then Will Satterthwaite says, are there any plans to allow for incorporation of uncertainty in observed values?
That's a very good question. Yeah, when we started the project, we actually had columns for coefficients of variation in our time series, right? We quickly realized that given the way we are incorporating uncertainty and the way we are running retrospective evaluations, it was not really essential. So we focus our efforts on other areas, right? We're definitely open to consider that again and to explore the cost benefit of doing that.
Awesome. All right, great. Leon Kwong says, is hatchery influence accounted for?
Hatchery influence, well, you can use it as a predictor. I mean, that would be the way, or as a covariate, right? And in this case, when we run the return rate, I mean, this model here, I mean, hatchery releases it can be the main predictor, right? But it can also be one of your environmental covariates if you are running the complex yielding regressions. Yeah. Okay, so I think that I'm looking at the time here, so I probably move on, right?
Sure.
So that because we don't want to miss the compare tab is kind of after you explore, you spend good time exploring and say, well, you know, I really don't care about this model because it looks pretty bad. I don't care about this one. So you make a mental kind of selection, and then you go to the compare tab. In the compare tab, there is still some couple of menus here that are not relevant, like this one. H class is not going to do anything. This is important because it refers to how the plots are going to show. They can be shown by the rank or by the magnitude of the forecast. Right? This is you have to remember when we talk about retrospective evaluation, we are measuring error, right? The measuring of in that retrospective evaluation is capturing different statistical metrics like the mean raw error, mean absolute error, mean percent error. So as a user, you have the ability to choose which ones you want to include in your evaluation. Sometimes depends on your own philosophy about these metrics, right? Or whether you want to focus on accuracy, on prediction. And so I'm going to remove just a couple of these. So just because, right? I mean, but obviously there has to be some good reason, or at the end of the compare, you can actually see the effect of adding or removing different metrics, right? But all the error is going to be captured there. So when it comes to the performance measure type, right? This error, it can be, there are also different options. And so I may show just an example here. So these are your errors, and then you can use kind of for your metric, you can use all the blue numbers here. You can use everything that is in the green box, or you can use everything that is in this box here, right? So that will give you slightly different values in your metrics, right? And it's also a decision that the user has to make. And this is the need to take this decision is because you are dealing with brute years. Some of those are going to be completed, some of those are not. And so when you start seeing the number of forecasts, the number of years used to fit your models is going to be changing, right, for different ages. So it's a decision that has to be taken as well. It's not going to have a large influence, but it has some effect. So the balance is a safe way to start. The interval type, that one is, I mean, when we were looking at that plot, talking about, sorry, talking about good attributes of forecast, we realized that including uncertainty was very important. So the decision here is very important. So there is a retrospective, prediction, and bootstrap. obviously the bootstrap is the more robust, but it takes more time, right? So I don't think I'm going to run it, the bootstrap. I'm going to run it. If you select the bootstrap, then you select the number of samples, and there are two types of algorithms there, right? I'm not going to go into that detail. So I'm going to leave it like this, right? I'm going to use my entire time series. I'm going to seed the first retrospective at 15 years, and then I'm going to decide which models to incorporate. Some of them are already pre-selected. You can leave them out of your evaluation. We have a naive 3, right? We have a naive 5. We have a time series model. In this case, is the ARIMA with the box-Cox transformation. And then we have an ARIMA model without the box-Cox transformation. We have an exponential smoothing with the box-Cox, exponential smoothing without. And then we have all the sibling regression family. I'm going to include just the simple sibling regression here. Then we have the log power. I'm not going to select it now. I mean, the more selections you make, obviously, the longer it takes. Another option is to have, which one is this? Oh, this is the Kalman. Okay, yeah, I'm interested in that one because we saw a trend in the intercept. And then here you have the complex sibling regressions will have the covariates. So yes, I'm going to select that one. I'm going to leave the default tolerance values there. I'm going to select also the return rate model, right? Which in this case is using as a predictor the hatchery releases, right? And then you can add more models here, right? So for a serious, I mean, after you did your exploration and probably run some comparisons, for a true forecasting that say, okay, this is for real now, I will select the bootstrap and I will select 250 samples, 500 samples, right? Just to be sure that the results are robust. So I know I was trying before how long it took if I select the retrospective, which is not pretty good in terms of the kind of the size of the interval, right? It's going to be pretty rough, but in terms of time, it's going to work relatively fast. So once you select your models and you click point forecast, the calculations are going to start for your model selection. So here we go. Hopefully, can you see the spinning wheel there? I don't see it here, but there should be a spinning wheel.
I don't see a spinning wheel. It just has like a download button.
Okay, well, if you don't see the error message, probably it's working. Oh, I can see the spinning wheel now, okay. So it shouldn't take long with the retrospective because the information is already there. It's just kind of just parsing the data and yes, to making the model selection exercises there. So come on. I think that we are good with time and we still have a few minutes, but I would like to leave enough time for additional questions. If it doesn't come out, oh, there it is. I was about to jump to plan B, which are my slides, my backup slides. So this is, I mean, in the Explore tab is really powerful because you can explore things immediately, right? But this I mean, we believe that is the great value of Forecaster is that now you can see, in this case, the point forecast, right? By age and total, right? And I'm going to move just the video part here that is blocking some things here. I cannot see. Oh, okay. And at the end, you have the totals, right? And so you can see how you use the same model, for example, for all ages, this will be your total, right? If you follow that approach, then you can see that there is a range of values, right? From the lowest value from the complex sibling, I think the largest value is going to be this 20,000. So, and yeah, so and you have here all the models that you selected. Now, this rank is what is the rank of particular models across ages. So always the one with the lowest value is going to be the best, right? So in this case, saying that this, I think this ARIMA with no box cogs has been identified as the best across ages. Right? Here you have your prediction intervals, right? You have your percentiles here, right? So this will be the median, and then you have your model selection. So here, ForecastR is saying that based on our choices, right, the return rate model was the best for H3, right? And then you can see here the point forecast, and then the interval, the information from the interval forecast, and then compare with the medians, right? I mean, usually the value of the point forecast and the median, if the exercise is good, are pretty close, right? But then you have 3 types of totals here, right? Oh, before I go there, so you see the Kalman regression was important for H4, the ARIMA with box cogs for H5, and the complex siblings, so it did a great job for the H6. Right? So you have 3 types of total. It depends a little bit on the philosophy of the user or the specific question that is trying to answer. Right? This mix is basically saying it's okay for me to have one best model for each age, right? So this will be the sum of these values here. Other people maybe they want to do the analysis at the age specific level, but they are only interested in the total, right? So then here we have what is the best model for you just focus on the total forecast from all ages, and then you have your forecast information here. And this is the model that is going to be the best across all ages, right? Which in this case is the same one here. So that's why the values don't change. And then really cool that you can see this kind of in figures there. So you can see that there you have your total, right? And you can see that there is lots of overlap between the different models. That question that we had, and this is mostly because we selected the retrospective here. If we have selected the bootstrap with a large sample, the overlap will not be that much. It will be different for sure. And that's where that question of model averaging that we got before, it really will answer important questions here in cases like that. So you can have it by age or as well, right? So you can see how things look. So there is a model that the complex sibling did very well for H6, but look, there is lots of uncertainty based on our choices here. And then there are some ranking details, right? So here you can see the ranks by age, right? You can see the total rank, if total abundance was your focus, right? And you can see the rank sum that is going to tell you which one is the best across ages. In these secondary tabs, right? We also have the performance by age. Here you have the mean row error, absolute error, percent error, and so forth for all the metrics, not only those that you selected, right? For all of them, but when you go to the next one, right? In this one, we have only the ones that we selected, right? And as I said, if we say, okay, you know, I really want to incorporate RMSE, it may take a while because then it will need to recalculate things, right? But let's see. Oh no, it was really fast. So so we have now, we include the root mean square error. So the ranks change and probably the selection will change, right? So we can always go back and change and see if things change at all. So yeah, you can see here that before these two were the same model, now they are not the same. So so you have, the user has lots of opportunity to really explore things before making a final decision, right? So we're getting close. I'm just going to mention that have the ability to produce 2 types of reports, right? Short report, long report. You just click here and the report is going to be downloaded. That report is going to include the tables and figures of whatever choices you made in the previous tabs, right? I'm just going to show you the first page here of the report. Oh, slow. Come on. So there you go, right? So you have an example of the report, and because this is in Word, so it's very easy to edit, right? Like for example, this table that is a little bit big for the page, but you can always just kind of fix things on the go. So this is an example of the loan report, and I'm not going to go in more detail, but basically it captures all the tables and figures relevant for you. And then I will go back now to the presentation. And so you can see I already have lots of Plan B slides there. So this just to say that if I run the Bootstrap with 250 samples, right, and selecting 12 models, in my computer, it took about 4 minutes, right? So if you select 500 samples, it may go up to 7-8 minutes, right? But this is getting closer now to what I will call a formal forecasting exercise. So I just have a couple of slides, and that will be it. So just as a matter of kind of final remarks, right? I was putting together a list of kind of conclusions or big thoughts, and I realized that some of those conclusions about forecasting were true for life in general as well. So what we have here is kind of these big truths that are true for forecasting, but for life in general as well. So tools make life easier, that is for sure, right? But still many decisions have to be taken along the way, right? In addition to that, different philosophies are at play, right? So that may change how you use the tools, right? But at the end, I think that the bottom line is that tools cannot replace creativity. And I believe that Forecaster provides the opportunity for lots of creativity. And finally, I just want to acknowledge the Chinook Technical Committee for all the support, contributions, participation, and also Solve Consulting for getting the Shinyapps to the state of the art that you saw, and also to all the users that really their feedback has been crucial for us in developing this tool. And I recognize the funding coming from the Commission, appreciated, and also from Fisheries and Oceans. And here at the very bottom is again this link to the main repository where many of your questions may be answered. So we have almost no time for questions, maybe one or two, I don't know.
maybe not. I think we're running out of time here, but I did forget to mention that the presentation and will be posted on the Pacific Salmon Commission's YouTube page, so you'll be able to watch this again. I do have a couple questions in the chat here, but I'll have Antonio follow up offline with those.
That sounds fantastic. Okay, great. Well, thank you very much, everybody, for joining today, and see you soon.
Thank you, everyone.